I'll record it here, but I will then save it for you guys for later. So I wanted to talk about databases particularly because pretty much all of you have data that we need to deal with in terms of databases, and we'll organize that way. Part of this in the well, I'll say two things. One is the reason that I feel important that I track the central data and then I maintain the master databases because we've had some problems in the past. So one of my very, very first grad students missorted an Excel spreadsheet and ended up finishing her entire thesis, and the data were all mismatched and weren't correct. Fortunately, didn't affect her interpretations, fortunately, because I didn't discover it until after the fact. But I sort of decided if I am the sort of financial responsible person on grants, that I need to maintain the data from the standpoint of the grants and the financial obligations. So that's sort of why I've been doing it. But I did a lot of this when I was working in consulting, not so much structuring the databases myself, because we had a whole group that did that work, but I worked with them a lot. And all of our data needed to go through them because they needed to maintain that sort of central database. So I have a lot of different experiences with these, and that sort of part of what you're going to see is just the bias. Also, I've just sort of taught myself a lot of this, or taught myself via watching YouTube videos when I get stuck, or actually have a friend who's a certified database person who helped out a lot in grad school. So part of what mine is self-learned and always isn't the most efficient way to do this. So with all those caveats, what I really want to do is just sort of give you the biggest picture overview and then show you a database so you can see exactly what it is and what you can do with it and why you want to maintain your data like this. So, I mean, a database is just tracking data is all you're doing. I use Access because it's free with Microsoft Word. It's just the simplest sort of thing. It's fairly intuitive on the whole. So I just stick with that to make life easier. So there's different things that exist in a database. There's tables, queries, forms, and reports, and I've got them all listed there. We mostly just use tables and queries. So tables are basically just spreadsheets. That's all they are, just like an Excel spreadsheet. They've got some different kinds of rules, but that's it. So when I talk about a flat table, all that means is all the data is in one table. A relational table is when we have tables that are tied together. So you can do some tying together in Excel, but mostly what you're dealing with in Excel is flat table. That is, it isn't tied to other things. Once we put all of our data into these kind of flat tables, then we can pull data out and calculate things from the data and recombine the data all different ways in queries. So we do both of these quite a bit. Often what I do is, because I need to maintain that central data, is I will set up the tables and sort of the basic structure of the database for you, so you won't have to do all this from scratch. And then when I give it to you, I usually do that with a date, so I know exactly which version you have. You can write queries and pull all kinds of data from queries. Some of them are predefined, and you'll see what some of those are. I rarely use forms or report. Forms are particularly used as a way to enter data. So if you were having like an undergrad or someone enter data and you wanted to make sure they entered it in a really consistent format when they type it in, you might set one up. I very, very rarely use them. Reports are just a way to summarize data. Again, I rarely use those. The only time I have is to say if I'm reporting back to landowners and I want all the landowners to have sort of the same data. So tables and queries that we're going to talk about today. So just to tell you a little bit more about them before we look at the database itself. So the table is just a spreadsheet. And just like, we have columns and rows in databases, columns are generally referred to as fields, not as columns. They're the same thing. And rows are records. So you have so many records of data as opposed to rows of data. In the columns, there's lots of different formats you can use, but any column can only have one format. So that's a huge difference from Excel. So Excel, you can have text in one cell, and then the next cell underneath have a date, the next cell underneath have a number. You cannot do that in databases. You only have one format per field. And that's going to control some of the structures we're going to use. Rows, the important thing about rows is each row has to have some sort of a unique identifier. Generally, I let Access create that for me just to make life a little bit easier, but I'll show you some examples. So this is the sort of, when we talk about a relational database, it means we have different kinds of information on different tables, and we're going to tie them together. And you do that via relationships. And this is a lot what it looks like. But so here, this is some water chemistry data, and I've sort of tried to put together a framework so you can see what kinds of data we have. So tracking IDs, that's what we give our each sample. gets a tracking ID, and that is unique to that sample. That is, when you take that sample, that's the only one that's ever, ever, ever going to have that name. So that's going to have a date and a time when you collect it. And how we define those tracking IDs depends on the project. But so, example here, Old Sweet is the location. S13, the S just means it's a regular sample as opposed to a QC sample or a duplicate or some special other kind of sample. So S just tells me it's a regular sample. 13 is the year, and then I have the date. And I've broken the year and date out this way to make searching easier, because sometimes we want to search for all the data in a certain year. And there's some advantages to doing it this way. So that's a kind of tracking ID we often use. It says something about the location and something about the date, and it might tell you about what kind of a sample it is. Sometimes we base this on what the project is. So I think with Lauren's, we're just calling it, we call them LR for Lauren Rockwell, something like that. But clearly, we don't want every sample you collect, especially if you're going back to the same sites over and over again, you don't want to have like all the GPS coordinates for every single sample, which is, if you did that, you'd add all these extra rows that you don't, or extra fields that you don't need. So tracking IDs link back to a location code, and that's actually just about the location. So that's information you only need in one place, and you never want it in more than one place. So things like GPS coordinates, which interestingly enough aren't listed there. What project it is, perhaps, any kind of location about the information that is just needs to be kept once. Sometimes we keep information like landowner information, a description of the site, anything like that. Once we have tracking IDs, so all that's in that tracking ID table is purely just the tracking IDs. There's no data there. It's just the information about the sample, not what the chemical data is for the sample. So then I can link that to numerous tables below. So one is, I typically have field tracking, some sort of a field data table. Alkalinity, sometimes we put in there, sometimes we put it in its own table. We have chemical data tables that have all sorts of chemistry data, and then lab data tables. These Z data tables, and you can see I've called them Z data tables, are things that are raw data that we need to manipulate before we can really use them. So for example, carbon, we'll look at that here in a moment. This is how they're tied together, and it can be something fairly simple. So here, this is a fairly simple one. We just have our tracking IDs going to location codes. Here we have meter data, ALK data, ICP data, IC data, so that's cations and anions. And also, when you calculate your freak data and all your various parameters after the fact, we can then incorporate those back in later in the process. So that's sort of handy, because then if you wanted to print out, say, pH versus PCO2, you can do that easily, versus trying to combine those data sets some other way. So the power in this is being able to combine data in different formats. This is a slightly more complicated version with some CO2. In this case, we had multiple sites on given landowners, and we had to track landowner details closely. So there's some information like that on here. So again, we design these depending on what the project is and what kind of information we need for the project. Okay, the CO2 and the DIC data, these are a little bit different. So the first thing we do for the CO2 and DIC, because many of you have these, we enter all the raw data. So every piece of data, all the replicates, and they're entered with the same tracking ID. So if it's the same sample and we just have 3 versions of it, we're going to enter the replicates in this raw data table. I'm then going to use a query to calculate the concentrations. First, I need to adjust them for temperature. And then once I've done that calculation for every sample there, I can then calculate things like means and average concentrations. And that's all done within the database. I'm going to show you this on the database. I just want you to be sort of prepared. Well, maybe we'll come back to this then afterwards. DIC is basically the same thing. We start with raw data in our raw data table. I have a query set up that corrects the data for temperature first, which is the same query as we do for CO2. Then we have to calculate the DIC from the temperature corrected CO2 data, and then we can collect or calculate the stats. And this will make more sense when we look at the tables. Oh, I just want to say this is a YouTube channel. This guy has a fabulous introduction to access. So you just look up Mr. Long Education. I have no idea why that, maybe his last name's Long. I don't know. Anyway, look up Access Mr. Long Education. You'll find great stuff. Okay, so here's an Access database I have set up. I took one of the ones we use and I've simplified it down quite a bit just so we can look at a few things. So the first thing you see when you open this up is on this objects over here, I've got tables. So all of my tables are listed. And I've got, as I promised, location information, tracking IDs, various data tables for field data, alkalinity, anions, ICP. I have discharge on this one. And then I have those Z tables that I call my raw data tables for DIC and CO2. And then I have queries down below. And those queries are places I've asked questions. So the ones that start with calculate, that's actually doing a calculation of the DIC from the Carbo QC data. So if it says calculate and query, that's something you want to leave in place. If it says stats, that's one of those places I then combine the data into something more usable. Let's look first. If you look under database tools on the top, what's going to be very useful here is what's called relationships. And it's on a different screen. So the relationship screen, and you can move stuff around on this. Wish I knew how to just shrink it, but I don't think I can. All it's doing is showing you how things are related. I'm trying to get them all on one screen here. I did this on my home computer for you last night and spread them out, and apparently that doesn't work on this screen. This one down here, got a table here. So the relationships tab defines how things are related to each other. So again, that whole idea of relational databases, that there are joins and relations between the data. Okay, I think you can see. Oh. Sorry about this. Bring that one down. Let's see if I come over here. Okay, you can see the basics here. So the tracking IDs is as promised, all the tracking IDs ties to the location information. So you'll see this little join here, as it's called, and see that arrow. That arrow tells me about what kind of join it is. If I left click on that join or double click on it, it gives me different types of joins. So that just tells me I have the table tracking IDs and the table location information, and that's where what the join should be, is between the location codes on both. If I look at the join type, I have some choices here. So I can join only when the rows are equal. But what I do, because we have a great deal of data in our tracking IDs, I typically include all records from tracking IDs and only those from the other table where the join fields are equal. And you can do that either way, as you can see there. So you need to be a little careful on what kind of joining you define. If you only use them when both tables are equal, if you have a table that's missing information, then you're just going to lose it. You won't have it there. Okay, so that's what this whole join, what this tells you about. So for example, all of these other tables I have here just go to tracking IDs. I have stats Carbo QC. So here, this is actually not a table, but it's a query. So I can, in my relationships, put a query in instead of a table, because I only want that final data from the CO2 and the DIC. I don't want the raw data. So I got field meter data here. I've got lab ICP data, lots of it. I've got Q discharge. Anyway, I think you see the point, even though they're poorly organized. And notice all of these tables come into the tracking ID. So this code on the tracking ID table is that unique identifier, and it has to be on every other table that's coming in. So all of our data tables are tracked and combined via the tracking ID table. On the other hand, this table, our location information, it ties to the tracking IDs via the location code. And there's location code, you can see, is on both tables. So how one table joins together may be not how all tables join. So this is the relationship page. And we could, I don't want to do it right now. I mean, I'll get rid of discharge. We might not need that. So I can just remove discharge. remove anything I like. I can also, let's say I did want discharge, I can bring discharge back just by dragging it over. It recognized tracking ID, so it just automatically linked to tracking ID. And if I double click on this, I can check the join type. And I have all records from tracking IDs and only those from records. Which order these appear in depends on how you drag them relative to each other. So it's sort of, there's some positioning that's important here. That's why I always like to check them. Okay, so I'm going to close my relationships. Do I want to save them? Sure. So that's important because that tells me how these pieces of information are tied together. So let's look at location information. And this just is different sites. And again, you can put any information in here that's useful. This has got project information, so I know that it's related to a specific project. I have coal seam, coal mine, county. A location code, that's what I use to link the locations together. What date I added it to the spreadsheet, because that can be helpful. What kind of water it is, landowners, GPS coordinate, who actually measured some of the various pieces of information. Oftentimes, if I'm working on a publication, I might have a column if I'm including that data in that publication so that I can always go back to the same data set. Okay, so that's location information. It's pretty straightforward. We'll just get rid of that because we don't use that a great deal until it's time to say plot our things in GIS. So tracking IDs, this is one of the real workforces of the whole thing. We have tracking IDs, which is that one that's got both location and the date combined. We have the location ID, which lets us tie to the location information. The year, the date we entered this, that kind of information. S tells me what kind of a sample it is. So these are mostly S's here. MDL, we also track method detection limits. I track duplicates as D. So let's say you wanted all the samples that you had duplicates of. You could just search for D. Comments, who collected them, information like that. So this is referred to as the spreadsheet view. Over here in the upper left, under views, I have a couple options. One is the data sheet view. So the data sheet view is what I'm in, and that's where all the data lives. I can also go to the design view, and the design view now is telling me about the properties of the table. So going back to spreadsheet view, notice the labels on the top of here, and they're mostly just textual information. When I come back to this view, those labels, the field names are listed vertically, and it tells me what kind of data they are. So for example, is it a text number, or is it a number, or should it be a date time? And there are lots of different varieties of these. And in fact, if you wanted to change it, you can just click there on the little caret and it'll give you lots of options. It can be calculated, it can be a link to some other object, it can be a hyperlink. You see the options there. You also can put in a description if you want. So for example, under shaft, that is all about whether the sinkhole is flowing. And so I have a question in there, so it's clear when someone enters data, they can always come and look at this and say, oh, that's what it is. So here on the number, on all of these, you can come down below. So whichever row I click on here, you see down below, I have these field properties, and they tell me about what the field is. So if I have a date, I can come down, I can pick a format, my date. I just click on that box and I can scroll to whatever format I want. That's fine. Most of these you're not going to use for text. Short text gives you 255 characters. 255. If perhaps I know I don't need anywhere near that data, like my longest location code is only about 6 letters, I could just put 12 in there and that'll save me some space. Okay, I can't change it if it's already in a relationship, but when you're setting up a new table, you can change that. Number is an important one. So when you select number, you can pick field size, and by that, it has to do with the way it's stored. You never want to define something as an integer or long integer because it will truncate all decimal points. It doesn't round, it doesn't just keep them, it truncates them. So a double decimal or just double is the form that you want. So I always use double as my option. If I want to, come back to number. So double, you can pick a format with how many decimal places you want, whether it's currency, scientific, you have lots of choices there. Oh, decimal places, you can say auto, or you can fix the number of decimal places you want. So that's mostly what I use in that case. And you just move back and forth between these views Yes, it wants me to save it every time I move around. So if I enter data in here, it automatically saves the table. So unlike Excel, there is no undo. It will save whatever you've done. But when I toggle back and forth, it will ask if I want to save. So again, that's the data sheet view and the design view. So that's what a table looks like. A query, let me see if there's actually anything else. So let's just say you want to work with this a little bit. There's all kinds of filters built in. So for example, I could come up to location code, click on the little caret. It gives me all the location codes that are there. I could also say, oh, I want one that begins with LRM. So it will give me all the locations that begin with LRM. You can see it has a little filter symbol there so that you know it's not the complete data set, but some subset that's been filtered. I can clear that. Text filters maybe does not equal LRM. So that'll give me all the samples that do not equal LRM. So all the other samples. Again, I can clear that out. Excel, when you sort, you need to highlight the entire spreadsheet or the entire area of data. If you just sort one column and you just highlight one column, it will only sort that one column. That is not true in a database. So even though I'm only selecting, let's say I only want data from year 2020, even though I've only selected one column, it has done the same, it's kept all the data together. Does that make sense? So it's sorting the entire data sheet, or it is organizing the entire data sheet as I like. So let's say I only want data from 2019, 2020. So you can just select things from there. But I don't want all my samples. Maybe all I want are the duplicates and the method detection limits. I can sort just those. So there's tremendous sorting capabilities you can do here to find things you want to find. There are more advanced ones, but I find I can do a lot just by using these little filters. Now, type, because I've got two filters on, I only got the type I wanted for the years I wanted, but I could clear filter from years, and now I still have MDLs and duplicates for every year. So that's kind of handy. Field data, just to show you what some of these look like. Oh, the next thing is every table. I can go back here. Notice that I have two tables open and I can tab between them on top. So every table has to have an index. That is, it has to have something that's a unique identifier for every row. Now here we could use the tracking ID. But let's come down and look at our raw CO2 data. Our raw CO2 data, as you can see, because we put in replicates, I have the same tracking ID 3 times. So that is not a unique identifier. So this ID column is where I have allowed access to define the unique identifier for me. If I come over to the view, notice the little key there. That means it's the index key. I come home, create external data, skills, trying to find design. It's the primary key. So when I clicked on the column, you can see that little key came up that says it's a primary key. That's a unique identifier. And it's an auto number in that I just let Access do it, which is totally fine. If I wanted to use something different, let me go back to spreadsheet view. So in the tracking IDs, I could conceivably use my tracking IDs as a unique identifier. So I could come up here and just say the tracking ID, I'm going to make that my primary key. You can only have one, but that should work fine. Let's make sure. You must first save the table. Okay. Okay, there we go. The changes you requested are not successful because they would create duplicate values in the primary key. So somewhere in there, I've got the same ID twice, which is a problem. I don't want help. I'm going to get rid of this. And I'm going to change. I'm going to change this back to my primary key. So one of the reasons I let Excel do the primary key, and I just call it ID, is it simplifies things. And if I have a duplicate in somewhere, I can still work with the database, even though I have a duplicate. Okay, yes, we'll go back. Okay, so that's what the tables look like. Let's go back. We look at this raw one. Again, we've got multiple entries for that particular sample because we ran those in triplicate, but it's the same sample, we just have different concentrations. So this is the raw data. So let me get rid of the data tables. Let me show you what a query, how you would build one to start. So I would say create query design. I like to do these in design. So I can just set up my, just set up my relationships this way. So maybe I want data from my tracking table and I want pH, maybe I want location information. Okay, so all I've done is I just said add, and this adds those. And notice they already have joins because they have the join types that agree with what's in the relationships that we have defined. And now what I can do is just say, well, what information do I want to search? And I want to put something together like I want to know pHs by coal seam. Well, I've got pH, go to tracking ID, and location is here. But what I can now do, because they're tracked together or tied together via the tracking ID, I'm going to put in the tracking ID first, and then I'm going to say pH and coal seam. So I've now combined 3 data sets from 3 different tables. Now, if all goes well, we can hit run, and look at that. So those are all the tracking IDs and all the pH data we have for each different coal seam, which is kind of cool to be able to do this. To do this in Excel, when you've got things in different tables and you have to match things up, is a bear. It's a bear. And the other thing is, if in Excel you sort your data differently, then suddenly you can have a different answer, whereas this all just works. Sometimes, depending on if you have not defined your joins correctly, or let's say, for example, I have a duplicate sample for anions, but not for pH. This can create some duplicates in your output for your query. And I often take my query now and pop it into Excel because I can use it in Excel and do more with it and create graphs. But you do want to keep your eyes peeled for duplicates. I will say that. Yeah, but you can see the power of it pretty quickly. I just wanted to know pH. Oh, wait, let's go back to my view. Maybe I don't only want to know pH. Maybe I also want to know specific conductance by coal seam. Oh, there you go. Now I got that too. That's handy. I like it. Okay, so I'm going to just go back to view. I'm just toggling between. The SQL view there is if you want to write code, which I don't usually bother doing because I don't need to. Okay, so I'm just going to save this one. Sure, we'll save it. What are we going to call that? We're going to try it. First query. Leave it there. So now you see first query is listed down here. You can open any of these. So here I have field data plus CO2 and DIC. And you can see I've got the tracking ID, temperature, pH, conductivity, my average CO2 and my average DIC. Oh, you know, that'd be really slick to have coal bed information. So I'm going to add over here my location information. So now I can also add coal seam. And I'm just dragging stuff around for my query. Now I've got all that information with coal seam. I have never looked at the data for CO2 via coal seam. That's going to be interesting. So it's a way to explore your data. Okay, I'm just going to get rid of that query, put that back. And it has now saved it. So that's there. Just so you can see how I've got the CO2 and DIC ones set up. And I will work with you individually for those of you doing that. Here's my DIC. This is before we were doing the temperature correction, this particular database. So it doesn't have all the information that you are used to seeing. So when you pull up and you open the query, you just get the results of the query. So tracking ID, date, CO2 information. And I've kept a lot of the columns in here, like these gamma values. Partly, I think I was having problems getting the calculation right in this. So I kept everything as much as I could. Hydrogen, we take the mixture temperature K. Anyway, there's a bunch of little calculations embedded in this. You can see my K1 and K2 at temperature, and then my final DIC. So clearly I've built in some calculations. If we go to the other view, let's see what calculations we have. Tracking ID, date, that's all just data. But let's come over here. I want CO2 in millimolar. If I click on this, and I'm going to left click, on the label. So I'm here in this label that has a title for it, and I'm just left clicking to get build. And look at this. There's my formula. So all I've done is put in a formula here. It's CO2 in grams per liter divided by 44, in which for CO2 in grams per liter, I just picked a different field of my data sheet. So it's internally referencing to do the calculation. My gammas are fixed values, and I just put them in that way. I adjusted some things for temperature. Look at build. That was just converting temperatures from natural log to base 10, apparently. Log at K2, build. So there's a long formula that we use to build the temperature. And that's to adjust K2 for temperature. So this is all built in. And usually when I set up your databases, I'm going to build this in for you, just because then you have a consistent calculation. You're not having to copy this from Excel to Excel to Excel. If your data, your master data is stored in 20 different Excel sheets, you will get things wrong. There's no way you can copy things over and over again and not create errors. You also, what will happen is you make a correction. You decide, oh, such and such is wrong. I need to correct that. I mistyped pH. You will have to then find every single spreadsheet you have with the data and correct the same thing on every spreadsheet, which is not a trivial effort, and things go wrong. So here we have one master database, and you make that correction there. You can set up your queries so it will spit out whatever data you want in whatever form you want, but you will always want to go back to the master data set. Okay, so I'm going to cancel out of there, but you can see how we have various different calculations. And by the time I get to the last column here, I look at the build, there's my calculation for DIC based on all of the data that's already in the spreadsheet. So that works fine. Okay, so I can run that and it does the calculation for me. And I come over to the far right, and there we have numbers in millimolars DIC. But it still has the replicates. So all I've done here is I'm doing my calculations. I'm going to sort tracking ID. So we can see, yeah, there's replicates in there. So there's 2 of those first ones. The second one, I got 3. So I need now to take averages. And I do that using a different query. So I can start with that one query. And now I can create, and I have created another query that it says for each tracking ID, what was the date, how many samples were there, what's the average, and what's the standard deviation. So I'm calculating those stats. So this is sort of our final result from DIC, that average calculation from the replicates. And that's what you're going to want to then tie back in to your data tables. So just to look at this one in the view mode, here we've got, it's got something kind of interesting. So I've told it up here in the menu, you see this thing called totals. Went away, shows up. I'm just clicking it on and off. But when it's on, what it does is it allows me to group information by certain things. So I've said group it by tracking ID. So all the tracking IDs are grouped together. If they're the same tracking ID, they're grouped together. And date. And that's easy because they are going to group together, because 3 tracking IDs are the same, are all going to be collected on the same date. They have to be, because the date is in the tracking ID. And then what I've said, okay, so for DIC, let me just get rid of these. Let's just run this as it is. So all it is date. Let me get rid of the group by. Okay, so those are every possible tracking ID with the dates. So here, same tracking ID, same date. So now, let me go back in the other view, say totals, I'm going to tell it to group. So now I only have one entry for each tracking ID. It's grouped them together. Okay, let's go back. Now what I want to do is add some of my DIC data. So I'm just going to pull this down here. Now it's going to do group by, but that makes no sense. We don't want to group by DIC, do we? Because they're going to have different values, the replicates. So now I have to choose something different. I can do the sum, which wouldn't make sense. There's no reason to add them. But knowing the average, the minimum, the max, how many, I can to count them, the standard deviation, those are all very useful things. So let's say I say, what's the minimum? And I'm just going to drop this down here again and say, well, what's the maximum? I'm going to pull it down one more time, say, what's the average? So now when I do a search, it should give me minimum, maximum, and average. And you can tell I haven't done min and max before because the formats are screwy. So if I come back here, I can look at the property sheet and say my format, I want fixed decimal. Let's just make it 3. Do the same thing on max. My format is, sorry, I want it fixed decimal places. I think I can just put 3 in here. Now we'll try, see if I solved that. I solved it for the minimum. The format was fixed. So let's do that on the maximum. You have to be in the correct cell to get the right option. So if you don't see something you like show up, just click in another cell and you'll get there. Okay, now what we have is the minimum, maximum, and average values. So that sort of grouping allows you to do some basic statistics because that's ultimately what you want to know. Cool. Okay. I know this is a huge amount of information. Huge amount of information. But I wanted you to have a sense how it works. Let's do something else here. Okay, so this query is all very helpful, but I want to be able to sort them by site. So now, instead of tracking ID and date, what if I brought the site name? No, I don't want that. These two are not tied together. So let me put tracking IDs over. Because I didn't have the tracking IDs tied to this. So I can just do that by dragging tracking ID on top of tracking ID. So I want, which one? I want all the records from tracking IDs. Okay, so now I should be able to put the tracking ID back, but from a different table, and the location code. Sometimes you get errors. Get rid of that one. See if I get a run. So when you get a data mismatch, there are a couple things you can do. One is you close this and save it and reopen it because there's some weird things there. What's that one? Yes, I know it's a data mismatch. Oh, now it doesn't want me to open. So if it doesn't let you open the file, you can always open it in design view. Let's get rid of that. We're going to go back to this tracking ID. And I'm just going to bring location information over. And I can match these. Location ID, that's interesting. There's ways I can work around this, but I can't work around it quickly in the time we have left. So you're saved for that problem. But there are ways we can make it work. And the bigger databases will have that. So now it should run fine. We're back to maximum, average, and minimum. I could. Here's another one I could add from this, is I do have date here. So I could also group by date. And then that would put everything from the same tracking ID and the same date together. Which actually will be redundant in this particular data set. Okay, so you get a sense of the big picture. I'm just clicking things out. The advantage is, one, you have one master location where all the data live. So you don't go back to those 20 spreadsheets. You should be going back to this data set regularly once we have it built and running. The beauty of it is once you have it built and running, the queries will let you pop out data in any format you like. So for example, you could set up a query that says, well, let me take all my chemical data and export it in moles per liter to make it easier to enter into Freak. And I'm going to plan my output in such a way that the columns, as my data come out of Access, are exactly how I want them in Freak. And I'll always get them in the same order, which is awfully handy. Oh, I know what else I wanted to point out. I want to look at one of the chemical data tables. Okay, remember that a given field can only have numeric data or text data. It cannot have both. So look here at these two fields for chlorine. So every analyte, lab analyte at least, has two fields. The first one is the numeric data. So here we have chlorine, and that's all the numeric chlorine data. However, when it's not detected, I need to indicate that it's below detection. And that's how we use this field code. And that field, or flagging code, and it just is putting in the detection limit. And I've put less than to make it a text field there. So that's actual text. Now the USGS in their databases, in here, they're going to put -999999 like that, so that you know it's below detection. If you don't know that and you open up one of their data sets automatically and you're not paying attention, you will incorporate that value as a true value into all your calculations, which is a disaster, clearly. I think it's easier. So I've worked with the Army Environmental Center and the EPA databases, and they do something more like this. The EPA has a whole list of what they call flagging codes, which are exactly for this use, where they might come down and say, well, the flagging code here is J and B. And what does that mean? In EPA lingo, a J flagged data means that it is present below the detection limit. That is, we can measure it, but it's below the certified detection limit. So you know it's there, but it's not good quality. A B qualified data in EPA lingo would mean that it's there, but it also was present in the associated blank sample. So again, it's questionable. So information that goes into flagging codes might tell you something about the data quality, like, oh, is there some reason we should question this data? So flagging codes are used for that in a lot of databases, including a lot of the EPA and the federal ones. Like I said, EPA's got a really long list of what they consider flagging codes, and we don't really use those. But so for example, here, preservation error, possible preservation error. So you can see I've added some notes in here when there's something wrong with the data. Just so, or if there's something screwy about the data, I can always go back and look at that. Here we've got filtered information because this is the anions. As you can see, I've got lots of method detection limits. You also notice they're a little bit different on different dates. So that's the method detection on that date is 0.17, 0.119, 0.12. That's part of why we track detection limits from the lab, is they are not consistent. Sometimes you do need to know the exact one for that date. Again, I tend to bring in your raw data and I will set it up in this format for you. I've written lots of macros that will do this very quickly and do what we need. And because I know exactly what format we need, it's helpful to do that. Almost every table, I also have added a comments column. So you can add comments. Something's wrong with the sample. So what I say here, chlorine is pretty, it does not text. Chlorine is pretty high. So there's something sort of questionable about that data. I include the lab name because not all labs are created equal. So information like that. Okay, do you have more of a sense of how and why we want to use these now? At least a little bit. I realize this is an enormous amount of information in a really short time. It takes years to learn these really well, but if I'm doing the creation for you and sort of setting it up and putting it together, what I find is most students, you're in a position then where you can do all kinds of query, and it really will help your data analysis. And it will help the fact that you've got all of your data in one place and not on 20 different spreadsheets, which is really a disaster. Giant data sets don't work well in this. So people who have like continuous temperature data for 3 years, we can't really put it in this. The EEM data will not go in this. They're just too big a data sets. But we could hyperlink things like that if we really wanted to. So there's some options, but there are other ways to store that kind of information. What I would do is, as each of you kind of gets to the point where we have your database, Lauren's, we're just on the verge of setting it up. Amelia, I've got sort of pieces of it set up. Morgan's is almost completely done because it comes off of what Rebecca was doing. Happy to look at your data set with you individually, but William, and once you get yours to a point where we're starting to collect data, we will build it together. So you'll sort of see that process and you'll have a chance to play with it. But I'm happy to share one if you guys want to just play with them. And I really highly recommend Mr. Long Education, whoever he is. He's very, very helpful, and he breaks it into little bite-sized pieces of information. I was watching some of them this week just to get a sense of what was the important things I should be talking about, and he was enormously helpful. So I highly recommend it. Oh, okay, I think I'm now hoarse. I'm going to stop share, and I would stop recording if I could figure out how. Stop recording.